Hi, my name is Shannon Stellato, and during my presentation I'll be talking about landfill gases, their environmental impacts, and what's being done to combat this problem. So landfill gas is the natural byproduct of the anaerobic decomposition of organic materials. Bacteria decomposes waste in 4 phases as seen in the figure. Phase 1 is the aerobic bacteria consumes oxygen while breaking down carbohydrates, proteins, and lipids in the organic waste. The primary byproduct of this phase is carbon dioxide, and it continues until all the available oxygen is used up. Phase 2, the bacteria anaerobically converts the products from phase 1 into lactic, acetic, and formic acids, and also alcohols such as methanol and ethanol. Acids mixed with the moisture in the landfill and consume the nitrogen to produce carbon dioxide and hydrogen. Phase 3, the organic acids formed in Phase 2 are consumed by anaerobic bacteria to form acetate. Methanogens are established by consuming carbon dioxide and acetic acid, and the production of methane begins. Phase 1 to 3 occur within a year of the municipal solid waste being dumped into the landfills. Phase 4, the composition and production of landfill gas remains relatively constant for about 20 years. It is composed of about 45 to 50% carbon dioxide, 50 to 55% methane, and 2 to 5% of other gases such as sulfides. With the current state of our climate and unsustainable lifestyles, the slightest increase in global temperature can lead to catastrophic environmental events, which is why the Paris Agreement called to limit the global temperature increase to 2 degrees Celsius. 254 million tons of municipal solid waste were generated in the United States in 2013 alone, more than half of that being deposited in landfills. That's about 40,386 cubic feet per minute of landfill gas produced, totaling to about 21 billion cubic feet of landfill gas produced per year. With 50% of that being methane, landfills are the 3rd largest human-caused source of methane. Although methane only composes about 11% of greenhouse gas emissions, it is 28 to 36 times more effective at trapping heat in the atmosphere compared to carbon dioxide. The first step in the processing of landfill gas is collection. The 2 methods of landfill gas collection are through the use of either horizontal extraction wells or vertical extraction wells. The design chosen is site-dependent and based on specific conditions and time of installation. Horizontal extraction wells are useful in deeper landfills, but if designed well, both systems can be effective. The wells are connected to lateral piping that transports the gas to a collection header through the use of a blower or vacuum induction system. Condensate formed when warm gas from the landfill cools as it travels through the pipes must be removed or it can disrupt the collection system. Flaring is the burning off of landfill gas and is necessary to control the gas emissions that may exceed the capacity of the energy conversion equipment. The gas collected must be treated to remove moisture, particulates, and other impurities. The treatment is dependent on the type of energy recovery system employed. Boilers and internal combustion engines require minimal treatment, which includes dehumidification, particulate filtration, and compression, while many gas turbines and microturbines also require silohexane and hydrogen sulfide removal. The 2 main uses of landfill gas are to generate electricity and direct use projects. The 21 billion cubic feet of landfill gas has the potential to produce about 6,300 megawatts of power, or about 73 million BTUs of thermal energy per hour. Electricity generation from landfill gases is carried out mainly by internal combustion engines, gas turbines, and microturbines. Internal combustion engines are used for more than 75% of landfill gas energy projects, which produce about 800 kilowatts to 3 megawatts of power. Gas turbines are used for larger projects producing 5 megawatts or more. Microturbines and small internal combustion engines are used for projects that produce less than 1 megawatt of power. Cogeneration, or CHP, projects are increasing in popularity by providing greater overall energy efficiency. These projects recover the heat lost during the combustion of landfill gas to use somewhere else. CHP can be used with any of the aforesaid technologies. Direct use is the use of landfill gas by facilities within 5 miles of the landfill as a cost-effective and renewable energy source. To summarize, landfills are a large emitter of greenhouse gases, but actions are being taken to reduce these effects. The Landfill Methane Outreach Program, or LMOP, is a voluntary program that works with industry stakeholders and waste officials to reduce methane emissions from landfills. As of now, landfills in 48 states and 1 U.S. territory provide landfill gas for the production of electricity, heat, pipeline quality gas, or vehicle fuels. Landfill gas energy projects will capture an estimated 60 to 90% of the methane created by landfills. By using landfill gas as a fuel, the use of non-renewable resources like coal and oil will decrease, reducing the amount of greenhouse gas emissions.